So we did the first part. We did R1, section R1. We calculated that yesterday. We stopped there. We didn't finish. So we're going to go to calculate section R2, add them together, and we'll be done. Okay. So R2. So if we're doing R2, it's a different top curve, different bottom curve. The roles are switched. Okay. So the line is the top curve, and the parabola is the bottom. Okay, so let's make those switches. So we have negative 0.75x plus 6, that's the top, minus the bottom. Okay. Bounds. Well, we know the outer bound is 2.5 because they told us. They told us the dotted line was at 2.5. X equals 2.5. So we know that's going to be up here. We know the top bound is going to be 2.5. And then the dot, the red dot that separates R1 and R2 is going to be the left bound. And from our work yesterday, we found that it was 1.660. So that's going to be the lower bound. 1.660. Okay. We have enough information now. I mean, you can distribute the negative before you put into the calculator. There's nothing wrong with that. Or you can just leave it like that. It's up to you. If you distribute the negative, then you don't need the parentheses. But other than that, the rest is just calculator. Because this is a calculator question, we can use calculator on any parts. Okay. So if we go to the calculator, so that's the work we did yesterday. That's the number we calculated yesterday. So I have these two guys here. I have the two functions here. One of them is y1, one of them is y2. Okay. So to calculate the area, I believe you can use, let's see, is there a y1 in here? No, I don't think there is. I was trying to see if you could, instead of having to write the whole thing over again. So integral, oops, that's not what I want. Math integral. So I want 161.660, 2.5, the top. The first one is the line. So that's going to be parentheses, negative 0.75 x plus 6 minus negative x squared minus 1.5 x plus 10 okay. R2 is 1.660 3, 4. Okay, that's the area of R2. Okay. So R1 plus R2 is 4.082 plus 1.634, and we get 4.082 plus 1.634, we get 5.716. Okay, that's total area of both. Okay. All right. So that the next few are going to be different. They're not always going to be cut and dry like these guys. This guy was pretty cut and dry. Find the bounds, put the areas in the calculator, good. The guy in front of it, this one right here, we had to draw it, but it was pretty cut and dry. It's easy to see which one's top, which one's bottom. It's easy to find the bounds, right? Same thing with this guy too. Easy to find the bounds, pretty cut and dry, top minus bottom, okay? The ones they're going to give you aren't going to be so cut and dry. I mean, they're not hard, but you just have to think about them. You have to sit there and think. It's not just rote steps that you just go over, do the same thing every time. These problems all look kind of different. So one of the ways they're going to look different is sometimes you have to look at it differently in terms of y, okay? So looking at it in terms of y instead of x. Every other problem we've done looks at it in terms of x. Looks at it in terms of x, okay? This guy here looks at it in terms of y, okay? All right, Riley, I have your focus up here. Okay, I need eyes up here. Because if I don't see eyes up here, this makes me think, Mr. Flores, this is way too easy. Makes the next test really, really hard. Okay, I don't want to do that. So please pay attention. Okay, eyes up here. All right, so why? So now what you're going to do is you're going to kind of look at it, not bounds aren't going to be from left to right. Bounds are going to be top to bottom. Okay, so before the bounds were left to right. We had a bound to the left, a bound to the right. Now, since it's in terms of y, with respect to y, it's going to be flipped around. So the bounds are going to be top to bottom. Okay. Now, when do you do this? When you need to. They don't tell you to do this. They say whenever you need to. So let's look at the first problem. So same steps. It's the same exact steps. Okay. Sometimes we will be given equations that are in terms of y. Or it will be easier to calculate the area if the functions are in terms of y, okay? In either case, the steps are similar, except that we integrate from bottom to top instead of right to left. It means the bounds are going to be top to bottom, okay, or from bottom to top, okay? So steps are still the same. Steps are still the same. Okay, so when do we use this method? This is one example. This is one example of one. Okay, so take a look at the example. Why do you think it would be, what is different about this problem? Think about that for about, come up with the reasons why it's different than the problems we've been doing since the beginning of yesterday. Why is it different? Okay. So what's one reason why this is different than the problems we did yesterday? Yeah, it says x equals instead of y equals. We're used to seeing y equals, right? These are equations that are with respect to y. Means the roles have reversed, right? X and y have reversed. So you can solve for x, or sorry, solve for y. You can do that. You can over here, you can take the square root of both sides, right? But then you got to deal with the plus or minus because it's going to be plus or minus the square root of x. right? Over here, it wouldn't be that bad. Subtract 2 from both sides. That's not that bad. But this guy over here, it's kind of a pain when you have to take the square root because you have to take into account the plus and the minus. Okay. So what we're going to do is we're going to leave it that way. Okay. No picture. First thing you're going to do. I see this all the time. One of the reasons why students miss these problems is because there is no picture and they refuse to draw a picture. It's too elementary school to draw a picture. Okay. Trust me. I've taken the highest levels of math you can take, and we draw pictures the whole time because pictures are easy to see. I'm a visual person. If I can see something, it's a lot easier to do. Okay. So first thing I would do is draw a picture. We got 3 equations. Let's see what they look like. Okay, because right now I don't know bounds. I don't know top. I don't know bottom. I don't know right. I don't know anything about it. So if I draw a picture, it's going to help me. Okay. So I'm going to draw a picture real quick. Okay, the first one is y equals x squared. Y equals x squared. How do I graph that guy? What do I do to graph? How do I graph y, x equals y squared? I know if it was the other way, y equals x squared, I would plug in, I know what that looks like, a parabola, right? I plug in numbers for x, see what y, and it's going to look like that. Something like that, right? But now, this guy is not that. It's close, but it's not that. So how do I graph that? How do I graph that? I'm not necessarily care about what it looks like. I'll figure out what it looks like, but how do I graph? What are the steps I can use for graphing? How can I graph things? It's not a calculator question because it doesn't say anything about calculator in it. So I can't use a calculator. What's one way I could graph it? Yeah, I would say plug in points. Plug in points. Okay. Probably the first way you were taught to graph a long time ago. Plug in points and see what you get. We got an X, we got a Y. What's the difference here though? Yeah, there you go, right? I usually plug in numbers for X and solve for Y, but now it's going to be reversed, right? So I'm going to plug in numbers for Y and solve for X. Okay. So I don't know. Let's plug in some numbers, see what happens. Let's see. How about -1, 0, +1? So -1 squared is +1. 0 squared is 0. 1 squared is 1. Okay. So let's see what kind of picture it comes up with. 1, -1. 0, 0. 1, 1. Okay, let's keep going. 2, oops, not that. 2. 2 squared is 4. Okay, so 2, 4. Okay. Two, 2, 4. Oops, I did the wrong way. Thought that looked weird. Supposed to go 4 up 2. There we go. So it's kind of looking like this. And if I were to plug in other negatives, or if I were to plug in other negatives, it would look like this. Okay, if I were to plug in -2, you would get 4. So 4, -2. Okay. So it looks like a parabola, it just turned on its side. called a hyperbola. Hyperbola. So that's when it looks like that. Okay. All right. So same thing with x. Well, y equals 0. What is y equals 0? That's that one's kind of, we've done that one before. What is y equals 0 going to look like on my graph? Let's do y equals 0 now, because that one we've seen before. What is y equals 0 going to look like? What's another word for y equals 0 on the graph? Yes, it will have a y-intercept, but what does it look like? There's another name it goes by. Y equals 0, there's another name it goes by. What is it called? Not the x-intercept. Close. You guys are very, very close. Y equals 0. Okay, so y equals 0, right? Where is y equal to 0? This is the y, right? Where is y equal to 0? Right here. It's going to go through the origin, but what's another name for this line here? The x-axis. There you go. It's this line right here. It's this line right there. It's the x-axis. That's all this guy is. It's the x-axis. Anytime it has y equals a number, it's going to be a horizontal line. We just don't know where. This number will tell you where. Well, since it's at 0, it's just going to mirror, or it's going to go right over the x-axis. Okay, there's that. Okay, so now last one, x equals y plus 2. So we're going to do the same thing that we did for x equals y squared. I'm going to plug in numbers. Let me plug in the same numbers I plugged in earlier, -1, 0, 1, 2. See what happens. Let's see, -1. If I plug in -1, I get +1. If I plug in 0, I get 2. Plug in 1, I get 3. It's linear, so it's going to grow linearly. Okay. So 1, -1 down here. 2, 0. 3, 1. 4, 2. Use a different color. Okay. Okay. Okay, so what area am I looking for? Because I got a lot of areas bounded, right? There's some areas in here that are bounded by the 3. Well, 2 of them are functions. One of them is not a function. But what also does it say? What area in the directions does it say we need to find? Area under the curve or between curves. What else does it say? What else does it say that we haven't read, that we haven't talked about in the prompt, in the question? Mm-hmm. Only the first quadrant, right? Yeah, only the first quadrant. So let's focus just on the first quadrant. So the only area that's bounded, right? Bounded means closed in. The only area that's closed in is this stuff right here. That's the area we need to find. That's the region. I'll label it R. That's the region which we have to find. Okay. Okay. If we were to do this one like we did before, top minus bottom, what would be the problem there? What would be what is a possible problem if we were to do top minus bottom the way we've done it before? What would be a possible issue? Can anyone tell me what a possible issue would be if we were to do it that way? Yeah. Say it again. Say it one more time. Mhm. Yeah, you're kind of getting there. You're kind of getting to that. So this is what I see students say. Oh, the black function, that's the top. And the blue function is the bottom. Boom, do it. What's the problem with that? What's the problem with the black being the top and the blue being the bottom? Huh? If we were to use that and say, okay, the top is the black, the bottom is the blue, we're missing a piece. It would also calculate this stuff down here too, because that's where the black is the top and the blue. So it would do all of this here. That's not what I want. I just want the yellow or the orange part. Okay. So what about the black being the top and the red being the bottom? Would that work too? The black being the top and the yellow, or the black top, red the bottom. Is there issues there too? The top function and the bottom function? What's wrong with that? The black being the top and the red being the bottom. Yeah, you right? Yeah, it's not enclosed. If I were to take away the blue, because in that case I would have no blue. Blue would be gone. I wouldn't even care about the blue. It's not enclosed, right? So even if I did have bounds, it would also cover this part here. And like you said, there's no enclosure, so it would keep going. Where do I stop? Right? So there's an issue. Everything we've done so far is not working. So that's when we use these steps here. So we're going to look at it in terms of y. That's when we need to use this. Don't try to make a square peg filling a round hole. Sometimes I'll have students do that. They'll try to use what they think they do, use the steps earlier to do this problem. Nuh-uh. You got to use different steps, or else you'll get a number. You'll get a number, but it won't be the right answer. Okay? And if it's a multiple choice problem, guess what? Those numbers will be on there. They're distractors because they know where students are going to make mistakes. Okay? So we're going to look at it a little differently. We're going to look at it kind of tilted. So you're going to kind of tilt your head when you do this. So look at the orange. What I want you to do is tilt your head to the right. Tilt your head to the right. Just this part here. Just the R, just the region R. If you tilt your head to the right, what is the top and what is the bottom? So if you tilt your head to the right like this and look here, look at the orange, what is the top and what is the bottom? You could do it like that. No, it doesn't work that way. Just this region here. Yeah. There you go, right? Blue is the top, black is the bottom. If I look like this, if I turn it, I wish I could turn it that way, but it keeps turning on me, right? Let's see if you can see it on my iPad. So if I do it like this, the blue is the top, the black is the bottom, right? And then the red is one of the bounds. So I don't have to concern myself with the red, okay? That's what I'm going to do, okay? That's what I'm going to do. I'm going to look at it that way. So instead, you could either do it two ways. Turn your head and look at it that way, or you can just say, what's the right side? Because the right side is going to be the top. The left side is going to be the bottom, okay? So that's why it says right curve minus left curve, okay? All right, so let's set this up. So R equals The blue is the right. So the blue is the line, x equals y plus 2. How do I write that in here? How do I write that in here? The reason I'm asking is because these are with respect to y. Y is the boss now. X is not the boss. Earlier, when it's with respect to y, or sorry, when it's with respect to x, x is the boss. It determines everything. Everything has to say y equals, y equals, y equals, or f of x equals. But now the roles are turned. Now the boss is y. So anytime I plug in anything here, it can't say y equals. It has to say x equals. Okay. Luckily for this problem here, they already did that. They already did that. It says x equals and x equals. Okay. So when you're doing it this way, and you will need to, trust me, there will be problems where you need to do it this way. Solve for x. Okay. Solve for x if not already done. Okay. So the top is the blue. So that's going to be y plus 2. Okay. The bottom is the black graph, the sideways parabola. That's going to be y squared dy. Okay. Now I need bounds. I need bounds now. So when I'm looking for bounds, I'm not looking left to right. I'm looking top to bottom now. I'm not looking for bounds here to here, because this is another issue I'll see. Oh, right here, 0, and then right here where they cross. No, that's top to bottom, okay? Or that's left to right. Sorry, you got to go bottom to top, okay? So the bottom is going to be 0. Y equals 0, right? The top is going to be this dot right now. I want to use that color because I already used it. Right there. So what I have to do is figure out which y value it's at. How do I figure out which y value without a calculator? Well, even if you did have a calculator, you couldn't do it on a calculator. Calculator wouldn't do it for you because it's with respect to y. Calculator is very smart, but it doesn't do with respect to y. It only does with respect to x. So what's the only way we can find this dot here? I'll give you a hint. We've done it before. We did it yesterday. Mm-hmm. Set the equations that are crossing equal to each other. Yep. The blue and the black. Set them equal to each other. Well, the blue, the black, set those equal to each other. Well, they both say x equals. So if they're both equal to the same thing, I can solve for, if they're both equal to x, that means they're both equal to each other. If they're both equal to the same thing, then they're both equal to each other. That's like saying, I'm the same age as my friend here. And then someone else saying, I'm the same age as my friend here. Well, aren't we the same age then? It's the same thing, right? If one thing is equal to each other and another thing is equal to the same thing, then they're both equal. Okay. So we got to solve for y now. To do that, it's a quadratic. So you got to subtract y from both sides, subtract 2 from both sides. So you get y squared minus y minus 2 equals 0. Okay. So you factor it, and you're going to get y minus 2 plus 1. Minus 2 plus 1. So that means we're going to get y equals 2 and y equals negative 1. So that means that's where they cross. They're going to cross at these two spots here. We know one of them. Here's the other one down here. They cross at these two brown dots. We don't care about the bottom one. Why don't we care about the bottom, this dot here? I could care less about this dot here. Why could I care less about this dot? Huh? Say it again. Say it loud. Yeah, it's not in the quadrant we're looking at. We're only looking up here. We're only looking in quadrant 1, right? So this guy right here is where I want. Okay. So we know it's going to be positive 2. Y equals 2. So that's at 2. So the top bound's at 2. Okay. Non-calculator question. So we have to do it by hand, but it's not that bad. So you're going to get 0 to 2 negative y squared plus y plus 2 dy. Okay. So when we do that, you get negative a third y cubed plus 1/2 y squared plus 2y. And we're going to evaluate it from 0 to 2. Okay, so do it. Don't wait for me. Don't look up here. Do it on your own. This part you should be able to do on your own. Look up here when you're done. And we'll see if we got the same answer. Oops. 10/3. Good? Okay, awesome. Okay. All right. All right, so let's try another one. Let's try this one here. This one, they give you a picture. So this one graph is already done for you. And it's a calculator question using a calculator. Okay. So they got a parabola and they got a straight line. So it's bounded. The green stuff is bounded by f of x, which is the parabola, g of x, which is the straight line, and the x-axis, y equals 0. Okay? Find the area of the shaded region. So label it R to the nearest thousandth. This guy right here. Are we going to do this with respect to x or with respect to y? That's my question. Are we going to do it with respect to x or with respect to y? What would top minus bottom be? Right minus left. Take all those things into account. If you can see a top and you can see a bottom, do it that way. If you can't, then maybe we have to do it using with respect to y. Another thing you have to take into account is if we do with respect to y, so let's say we do this with respect to y, what's another issue we're going to have? There you go, right? G of x not that bad, right? G of x, change G of x to y, and then solve for x. That one's not that bad. Subtract 9 from both sides, divide by negative 1/2, negative 1.5, I should say. How in the world would we do that guy? How would we solve for x or solve for x? X equals for f of x. How would we do that? Because you got to take into account all these things. Because I don't want you to spend time on this question and then get to that and you're like, right? So think about these things before you start the problem. So how would we do that? If we're going to go top to bottom, right? And or left to right, I can see that being a good idea because this would be the top bound, that would be the bottom bound, right? The right one would be the line, the left one would be the parabola. Boom, perfect, beautiful. But how would we do that? How would we write that? Because if you don't have an answer, the answer is we can't do it. We have to find a different way. But that, I would see that's the easiest way. I think that's the easiest way. So how would we do it? Think about it. The answer is I'm not going to tell you. Okay, so think about it. You got to actually think. Mr. Flores is not going to give you all the answers. You guys are very, very smart people. You have to think.